Today we're going to learn how to use special pairs of angles to find angle measures. And in case you haven't figured out from yesterday, this is a pretty heavy vocabulary unit. So it's going to be important that you start learning and knowing the vocabulary. And so our first vocabulary word is adjacent angles. Adjacent angles are two angles that share a common side and vertex and do not overlap. So if you need to pause this and write that down, go ahead and do so. And then I'm going to give you an example so you can see what adjacent angles look like. You may want to draw this picture in your notes. So here's an example of adjacent angles. There are two angles that share a common side. So right here is the common side that they share, and they share a vertex. The point is called the vertex. And these angles are side by side, they do not overlap. So adjacent angles share a side, a vertex, and they do not overlap. Our next vocabulary word are vertical angles. Vertical angles are angles that are opposite each other. So pause the video and write down the definition, and then we'll do an example. So here is my example, and I've just done two angles that cross, or two lines that cross that make angles, and then I've labeled them angle 1, angle 2, angle 3, and angle 4. And so when we talk about angles that are opposite one another, angle 1 and angle 3 are vertical. They're opposite each other. And then angles 2 and angles 4 are also vertical angles. So congruent angles are angles that have the same measure. Geometry is kind of its whole separate branch, or its own little branch of mathematics. And so we have different words that mean the same thing as things that we're used to saying in other parts of mathematics. And one of those words is congruent. Congruent means equal in geometry. So congruent is geometry's word for equal. So instead of saying equal angles, we say that they're congruent, and they're just angles that have the same measure. A plane in geometry it's a flat surface, and like when I think of a plane, I think of a flat surface like a piece of paper, so that thin and that flat, but it extends forever and ever and ever. It never ends. So that's a plane in geometry. Parallel lines, and you're probably familiar with this. Parallel lines are two lines in the same plane that never intersect, and intersect means cross. So there are two lines that never cross. And an example of parallel lines will look like that. They can be on a diagonal, or they can be straight up and down or horizontal. All right, so they're just two lines that will never ever cross, no matter how far they go out. Intersecting lines are two lines that meet at a point, and the interesting thing about intersecting lines is they may meet where you can see them, so that would be intersecting lines. That's obviously because they meet at this point right here. But intersecting lines may also look like this. So even though they don't cross at a point right here where I can see it, I know that if my lines extend on out, they're going to eventually cross right there. And lines do extend forever and ever. That's why you have arrows on the end. So even if it doesn't look like they intersect in the part that you can see, if they extend on out and will intersect at some point, they're called intersecting lines. Perpendicular lines are two lines that intersect and form four right angles. So here's what perpendicular lines look like. and that would make a right angle, that would make a right angle, all the way around. So two lines that intersect and form 4 right angles are perpendicular. Corresponding angles are angles that occupy corresponding positions when a line intersects 2 other lines. So here's what that might look like. And in order for them to be corresponding, these lines must be parallel. So you might make yourself a little note, lines must be parallel. And then we've got a line that intersects those. And so the corresponding angles would be this angle and this angle. So notice how this angle right here is at the top and to the right of my lines. And then this angle is at the top and to the right of my lines. So then some other corresponding angles might be this one and this one. So see how they have the same position? And then you can kind of go through and see which other ones are corresponding. This one and this one are corresponding angles, and so on and so forth. Alright, so they have the same position when a line intersects 2 other lines. Let's look at some examples now. Example 1 says, identifying adjacent angles, name all pairs of adjacent angles, name all pairs of adjacent supplementary angles. Go ahead and pause the video and see if you can figure those out, and then come back and check your answers. So I know adjacent means side by side, and I know supplementary means 180 degrees or a straight line. So when I look at this, angle 1 and angle 2 are adjacent and supplementary. Then angle 2 and angle 3 are adjacent and supplementary. Then angle 3 and angle 4 are adjacent and supplementary. And then if I want to keep going in a circle, I can do that. Angle 4 and angle 1. If I want them in numerical order, then it would be angle 1 and angle 4. Those are also adjacent and supplementary angles. Alright, example 2 says using vertical angles, given that the measure of angle 4 is 105 degrees, find the measure of angle 2. Alright, their vertical angles have the same measure. So you might make yourself a little note. Vertical angles have the same measure. And remember, vertical means opposite. So if angle 4 is 105 degrees, then the measure of angle 2 is also 105 degrees. Alright, then it says use what you know in example 2 to find the measures of angle 1 and angle 3. Pause the video and see if you can figure that out. Alright, so I know that angle 4 plus angle 1 is supplementary, so it adds to 180 degrees. I know the angle 4 is 105 degrees, so plus angle 1 equals 180. I can use algebra to solve for this. So 180 minus 105 is 75 degrees, so the measure of angle 1 is 75 degrees. And then I know that angle 1 and angle 3 are vertical, so they have the same measure. So angle 3, measure of angle 3 is also 75 degrees. Alright, so here my thought process and my reasoning so that you are able to do that, and when it says explain or justify, you need to kind of be able to explain those steps. Alright, the last example, example 3, says the map shows a section of Houston. Streets shown on maps often appear to form parallel or intersecting lines. And then you are supposed to name 2 streets that are parallel and 2 streets that intersect. So go ahead and do that, and then find the measure. If measure of angle 1 is 85, find the measure of angle 7. I don't have the picture in my notes, so you will have to use your notes while you fill this out. Hopefully you already have this done. The parallel streets, and our notation for parallel is like two lines that run together. So parallel would be Dallas Street and McKinney. And those are the only streets that are parallel that are labeled. Then intersecting would be Travis and McKinney. Or you could have said Travis and Dallas. Either one or both is fine. All right, and then if the measure of angle 1 is 85 degrees, so I'm going to write down my thought process. Measure of angle 1 is 85 degrees. Then the measure of angle 3 is also 85 degrees. That's because they're vertical. And vertical angles have the same measure. And then the measure of angle 7 is also 85 degrees. And the reason for that is it's a corresponding angle with angle 3. And corresponding angles also have the same measure. They're congruent. If you have questions after doing this lesson, please come see me in the morning.